Wow, if you're learning JavaScript, or you've just started working as a developer, this video is for you. Today, we're going to talk about 10 common JavaScript mistakes that junior developers make all the time. These are not stupid mistakes. I made most of them myself when I was starting out. But the difference between a junior and a senior developer is knowing why these mistakes happen and how to fix them properly. So in each slide, I'll show you a bad example and then a better, more professional solution. Let's get started. Let's start with a mistake that almost every JavaScript developer makes. And when I say almost every, I mean including me. Yes, I made this mistake multiple times, and I was very confident while making it. I'm talking about using var without really understanding what it does. When you're a beginner, var, let, and const look like triplets. Same face, same job, different names. And your brain goes, okay, 3 keywords. JavaScript designers were probably bored. So you just pick one, usually var, because old tutorials use it, Stack Overflow answers use it, and it doesn't yell at you with errors. Or feels friendly. Too friendly. Now let's look at the code on the screen. We have a for loop. It runs 3 times. Inside it, we call setTimeout. Nothing crazy. If I pause the video here and ask a junior developer what this code should print, almost everyone answers 0, 1, 2. And honestly, that answer makes sense. If JavaScript were a human, it should do that. But JavaScript is not a human. JavaScript is a lawyer. It does exactly what you say, not what you mean. So what does it actually print? 3. And this is usually the moment where beginners stare at the screen like it just insulted their family. They refresh the page. Same result. They run it again. Still 3. And then they say, JavaScript is broken. No, JavaScript is innocent. You are guilty. Here's what's really happening. The problem is not setTimeout, not async code, not closures. The problem is var. In JavaScript, var is function scoped, not block scoped. In simple terms, there is only one I, not one per loop, just one single variable. Each iteration of the loop keeps updating that same variable. By the time the setTimeout callback runs, the loop has already finished, and I is already equal to 3. So all callbacks look at the same variable and say, oh, it's 3 now. Cool. At this point, some juniors ask, but why would anyone design it like this? Short answer, history. JavaScript was created in about 10 days back in 1995. This was not a carefully designed language. This was a ship-it-fast language. And var is one of those historical decisions we still live with today. Now let's look at the fix. We replace var with let. Same loop, same logic, same setTimeout. Suddenly, everything works. 0, 1, 2. No magic here. Let is block scoped, which means each loop iteration gets its own I. Instead of one shared variable, we now have 3 separate ones. This is how your brain thought the first code worked. At this point, some people say, okay, cool, I'll just use let everywhere. Better, but not perfect. This is where const comes in. And no, const is not scary. Most variables should not change. If a value doesn't need reassignment, lock it. Const is about safety. It tells your future self, this variable is not supposed to change. In future, you will thank you. So here's the rule you should remember. Use const by default. Use let when reassignment is necessary. Avoid var unless you're maintaining legacy code or reading ancient JavaScript from the dark ages. If you're writing modern JavaScript today and still using var, that's not a red flag. That's a siren. And here's the senior level takeaway. This mistake is not about syntax. It's about mental models. If you don't understand scope, you will struggle with closures, async code, event handlers, React bugs, and those mysterious, why is this undefined moments. Take the time to understand this now, because once scope clicks, JavaScript suddenly feels reasonable, almost friendly. All right, now that we've fixed var, let's move on to the next mistake. Versus equals. Let's move on to the next mistake, and this one is sneaky, because the code looks correct at first glance. I'm talking about using double equals instead of triple equals. This mistake doesn't usually crash your app. It's worse than that. It quietly waits until the worst possible moment, and then it breaks something important. When junior developers see equals and equals for the first time, the reaction is usually, why are there 2 equality operators? And then they hear someone say, they're basically the same, just use equals to. That advice has caused more bugs than we'd like to admit. Let's look at the example. We check if age equals 18. And guess what? JavaScript says, true, even though one value is a number and the other is a string. At this point, beginners think, wow, JavaScript is so smart. It understands what I mean. No, JavaScript is not smart. JavaScript is being polite. Too polite. What equals does is something called type coercion. That's a fancy way of saying JavaScript tries really hard to make the comparison work. It looks at both values and says, okay, these types don't match, but let me convert one of them so we can still be friends. Sometimes it converts strings to numbers. Sometimes numbers to strings. Sometimes booleans to numbers. Sometimes things get really weird. For example, 0 equals false is true. Equals false is also true. And yes, null equals undefined is true. If that makes you uncomfortable, good. It should. This is not flexibility. This is chaos. The danger here is that your code might work today, fail tomorrow, and you won't immediately understand why. Because the bug is not obvious. The condition looks reasonable. There's no error, no warning, just wrong behavior. Now let's look at the fix. We replace with equals. Triple equals does 2 checks instead of 1. First, it checks the value. Second, it checks the type. If the types don't match, JavaScript doesn't try to be clever. It simply says, no, and that's exactly what we want. With equals, 18 equals 18 is false. Clear, predictable, boring. And boring is good in programming. Boring means stable. Boring means no surprises at 3 a.m. when production is down. Some juniors worry that using equals everywhere is too strict. But strictness is a feature, not a problem. It forces you to think about your data. It forces you to know whether you're working with numbers, strings, or booleans. And once you build that habit, your bugs decrease dramatically. Here's the senior mindset shift. JavaScript already has enough magic. You don't need more. Avoid implicit behavior whenever possible. Be explicit. Be clear. Make your code easy for humans to read, not just easy for the computer to execute. So remember this rule. Always use equals. And when should you use equals? Almost never. If you don't have a very specific reason and a very good explanation, you probably shouldn't be using it. All right, now that we've removed one source of silent bugs, let's move on to the next mistake. And this one involves async code and promises, where things get confusing very fast. Now let's talk about async code, the part of JavaScript that makes many junior developers question their life choices. The classic mistake looks like this. Const data equals fetch URL console.log data. In your head, this feels logical. You fetch the data, store it, and log it. But JavaScript doesn't work that way. The important thing to understand is this. Fetch does not return data. It returns a promise. A promise is JavaScript's way of saying, I'll give you the result later. And JavaScript does not stop and wait. It keeps running. So when you log data, you don't see the result. You see a promise. This is not a bug. This is expected behavior. JavaScript is asynchronous by design because waiting would freeze the entire app, and users really hate frozen apps. The fix is using await. When you write const res equals await fetch URL, you tell JavaScript to pause this function until the promise resolves. Not the whole program, just this function. Then you usually need another await, like await res.json, because yes, that also returns a promise. Here's the senior rule. If a function returns a promise, you must either await it or use .then. There is no third option. Once you accept this mental model, async code stops being scary and starts being predictable. All right, now that async makes a bit more sense, let's move on to the next mistake, where juniors forget to handle errors. Let's talk about something junior developers are very optimistic about, the idea that nothing will ever go wrong. This is the mistake of writing code as if errors simply don't exist. No try, no catch, no checks, just pure hope. And hope is not a strategy. Look at the example. We call json.parse input. And when the input is valid, everything works. The problem is, input is almost never valid. Users type weird things. APIs return unexpected data. And sometimes the data is just broken. When that happens, JavaScript doesn't gently warn you. It crashes. Immediately. Junior developers often assume that if their code works during testing, it will work in production. That's cute. Production is a very different environment. Production is where users do things you never imagined, at times you never expected, on devices you've never tested. The fix is simple. Wrap risky code in a try-catch. This doesn't make your code weaker. It makes it realistic. Instead of crashing the app, you handle the failure, show a message, log the error, or recover gracefully. A broken feature is bad. A crashed app is worse. Here's the senior mindset. Errors are not exceptions. They are normal. They will happen. Your job as a developer is not to prevent every error, but to decide what happens when an error occurs. Good error handling is what separates a demo from a real application. So remember this rule. If something can fail, assume it will. Handle it. Your users will never thank you for it, but your future self definitely will. All right, now that we've stopped our app from crashing every 5 minutes, let's move on to the next mistake. Mutating objects and state in JavaScript. Now let's talk about a mistake that looks harmless but causes a lot of hidden bugs. Mutating objects directly. This is especially common with junior developers because JavaScript doesn't stop you. It lets you do it. And that's the problem. Look at the example. We write user.age equals 30. Simple, clean, and it works. So what's wrong with it? The issue is not this line of code. The issue is everything around it. When you change an object directly, you also change it everywhere else that object is being used. Junior developers often think variables store values. In JavaScript, objects are stored by reference. That means multiple parts of your app might be pointing to the same object. So when you change it in one place, you accidentally affect other parts of the app. And those bugs are painful to debug because nothing looks obviously wrong. This problem becomes much worse when you work with frameworks like React or Vue. You update an object, but the UI doesn't update. Or worse, it updates sometimes. And now you're confused, your users are confused, and everyone is unhappy. The fix is to avoid mutation and create a new object instead. Using the spread operator, you copy the existing object and override only the fields you want to change. This way, the original object stays untouched, and your changes are explicit and predictable. Here's the senior mindset shift. Mutation makes code shorter, but immutability makes code safer. When you treat data as something that should not change unexpectedly, your app becomes easier to reason about, easier to debug, and easier to scale. So remember this rule. Don't change objects directly unless you have a very good reason. Create new objects. Be boring. Be predictable. Your future self will thank you. All right, now that we've stopped breaking shared state, let's move on to the next mistake. Using global variables. Now let's talk about global variables, also known as the invisible source of bugs. Junior developers love globals because they are convenient. You define a variable once, and suddenly you can access it from everywhere. No passing parameters. No thinking. Just vibes. Look at the example. We have a variable called total defined outside of any function. Then inside a function, we update it. It works. Until it doesn't. The problem with global variables is not that they fail immediately. The problem is that they fail silently. Any part of your application can read or modify that variable. That means any function, any file, or any future developer can accidentally change it. When something breaks, you don't know where the change came from. Debugging turns into detective work, and not the fun kind. Junior developers often think globals make code simpler. In reality, they make code harder to understand, harder to test, and harder to scale. As your application grows, global state becomes a shared kitchen where everyone leaves a mess, and no one cleans it up. The fix is to keep state local and pass data explicitly. Instead of modifying a global variable, return a new value from your function. This makes data flow clear. You always know where values come from and where they go. Here's the senior rule. If you can't explain who is allowed to change a variable, that variable shouldn't be global. Limit scope as much as possible. Small scope, fewer bugs. All right, now that we've locked down our variables, let's move on to the next mistake. Writing huge functions that try to do everything. Now let's talk about huge functions. You know the ones. You open a file, scroll some more, and you're still inside the same function. Junior developers often write functions like this because it feels productive. Everything related to one feature is in one place. What could go wrong? The problem is that these functions don't just do one thing. They do everything. They validate data, save it, send emails, update the UI, log analytics, and maybe even make coffee. When something breaks, you have no idea which part caused the problem. Huge functions are hard to read, hard to test, and terrifying to change. Junior developers are often afraid to touch them because one small change can break 5 unrelated things. And when you're scared to change code, that code is already a problem. The fix is simple but requires discipline. One function, one responsibility. Break big functions into smaller ones with clear names. Each function should do one job and do it well. Smaller functions are easier to understand, easier to reuse, and much easier to test. Here's the senior mindset. Code is read far more often than it is written. Your job is not to write clever code. Your job is to write code that future humans can understand, including future you, who will not remember what you were thinking today. So if your function needs a comment to explain what it does, that's usually a sign it's doing too much. Split it up. Your code base will instantly feel lighter. All right, now that we've broken up our monster functions, let's move on to the next mistake, not using built-in array methods. Now let's talk about arrays, and more specifically, the fear of array methods. Many junior developers see map, filter, and reduce, and immediately think, this looks advanced. I'll just use a for loop. And yes, the for loop works. But that doesn't mean it's the best choice. Look at the example. We loop through an array, check a condition, and manually push items into a new array. It's long, it's noisy, and you have to manage indexes yourself. The logic is correct, but the intention is hidden inside too much code. Now compare that with filter. One line. Very clear. Give me only the users that are active. That's it. No counters, no pushing, no extra variables. The code reads almost like English. Junior developers often avoid array methods because they're not used to thinking in a functional way. But once you get comfortable with them, your code becomes shorter, cleaner, and easier to reason about. Less code usually means fewer bugs. Here's the senior takeaway. Loops tell you how something is done. Array methods tell you what you want. And when your code focuses on what instead of how, it becomes much easier to read and maintain. So don't be afraid of map, filter, and reduce. Learn them. Use them. Your future self will thank you when you don't have to debug a 5-level nested loop at midnight. All right, now that we've upgraded our array skills, let's move on to the next mistake, copying code without understanding it. Now let's talk about one of the most honest mistakes junior developers make, copying code from the internet and hoping for the best. And yes, everyone does this. Googling is not the problem. Copying without understanding is. Junior developers often find a solution on Stack Overflow, paste it into their project, run the app, and when it works, they think, nice. Problem solved. But what they don't realize is that they've just added a black box to their code base. It works, but no one knows why. Not even them. The real danger shows up later. The app breaks, or the requirements change, or the data looks a little different. Now that copied code stops working, and you have no idea how to fix it because you never understood it in the first place. Senior developers also copy code. The difference is what happens next. Seniors read it, rewrite it, rename variables, remove unnecessary parts. They make sure they could explain every line if someone asked. If you can't explain it, you don't own it. Here's the mindset shift. Code you don't understand is technical debt. It's borrowed time. It will come back to hurt you later, usually at the worst possible moment. So the rule is simple. It's okay to copy code, but never paste and run. Paste, read, understand, and rewrite. Even small changes force your brain to engage. And that's how you actually learn. All right, we're almost at the end. Let's move on to the final mistake. And this one is about skipping the fundamentals of JavaScript. Now let's talk about the final mistake. And honestly, this is the one that causes most of the others. Skipping JavaScript fundamentals. Many junior developers rush straight into frameworks. React, Vue, Next, whatever is trending this week. And that makes sense. Frameworks are exciting. Fundamentals are not. Junior developers often think, I'll learn the basics later. But later usually never comes. Instead, they end up memorizing patterns without understanding why they work. The code runs until it doesn't. And when something breaks, everything feels confusing and unpredictable. The truth is, frameworks don't replace JavaScript. They sit on top of it. If you don't understand things like scope, closures, the event loop, and how async code really works, frameworks will feel like magic. And magic is hard to debug. Senior developers don't know more frameworks. They understand the language better. That's why they can switch tools easily. When a new framework comes out, seniors aren't scared. They read the docs, connect it to what they already know, and move on. Here's the mindset shift. JavaScript fundamentals are not optional. They are the foundation. If the foundation is weak, everything built on top of it will be unstable. But if the foundation is solid, learning new tools becomes fast and easy. So don't rush. Take time to understand the core language. Learn how JavaScript thinks. Because once you understand that, everything else starts to make sense. And that's it. 10 common JavaScript mistakes. If you've made some of these, congratulations. That means you're learning. The goal is not to avoid mistakes forever. The goal is to make better mistakes, faster. Thanks for watching.